Good morning, everyone. Today I'm going to talk about graphical realism framework for industrial control simulations, specifically talking about cybersecurity for control systems and helping to train operators to be more aware of cybersecurity risks and also able to detect cyber attacks. So just a little bit about me. I finished my PhD at Georgia Tech in ECE in 2017. My research there focused on new attacks and new defenses for ICS networks. Through this, I gave a proof of concept talk on ransomware at RSA a couple of years ago, discovered multiple vulnerabilities in control system devices, several publications and patents pending through my research, and most recently presented at Black Hat USA releasing this graphics framework for training people on control system security. It's release free and open source that anybody can download and start using today. Through this, I also helped create the online cyber physical security course at Georgia Tech. We're currently incorporating the graphics framework there to help teach students on control system security. And also most recently, I founded and currently CEO of our startup, Fortified Logic, providing ICS network security and training there as well. So the problem, I'm sure all of you are aware now, the past few years we've seen attacks take down nuclear centrifuges, Ukrainian power grid, and a Middle Eastern oil facility. And it's really a question of when, not if, these attacks are going to happen in the US. And it's not an easy problem to solve because these PLCs are still being sold insecure by design, essentially. No or weak passwords, the life cycles are decades long, difficult to patch, no encryption. And it's not just a security issue, it's a process issue. So I've talked to several customers about how they have no idea what's actually on the network. They had their vendor come in, install all kinds of stuff. They don't know what's there. They don't know how to patch it. They don't know how to keep track of what's going on. And also the vendors logging in, performing maintenance on devices. They don't know who's logging into what they're doing, and occasionally logging into the wrong PLC, changing some things and causing some downtime and lots of money. So it's a big issue. And finally, there's not enough personnel with ICS security expertise. So every month I see a headline on the talent gap in cybersecurity in general, but the gap in control system security expertise is even bigger. And existing training programs are not sufficient to fill the shortage. They're not scalable. They require on-site training, and who has time to go travel to Idaho to work on the Idaho National Lab course there. They're not realistic. They don't really give trainees the consequences of these devices are insecure. If something happened to them, something really bad could happen. And they're not engaging. So they usually only have like one little PLC up at the front of the classroom. And it's not really, it doesn't really feel like a real environment. It's not engaging for students to actually draw the conclusions and the relationship between cyber attacks and physical consequences. And finally, these networks are becoming more connected every day. The problem's not going to get any easier. It's only going to get harder. So ICS personnel must learn to deal with these increasingly complex networks. So our solution is virtualized ICS networks using engaging 3D simulations of the physical process. So a chemical plant there is the open source free version that we have currently online. So going into more details, this is a complete virtual network. So we have an HMI engineering workstation there at the top. You can use that to program the virtual PLC there. The virtual PLC is then polling all these 6 remote I/O modules down there that are monitoring this chemical process simulation that's actually dynamically going on, being visualized in that game engine. So it's real software devices generating real network traffic. You can get real practical experience in various aspects of network security there. And the main idea here is we wanted to basically give operators, give trainees a sandbox to play around and see, this is basically like a digital twin of a simplified process, play around with it, see how vulnerable it is, see how easy it is to attack things. And then once you appreciate all that and understand all that, go backwards and work through and figure out how to defend that network, how to make it more secure, and all that. So at every level of the network, you can practice various, both just normal IT security attacks, but also ICS specific attacks. So at the top, we're running advanced HMI, just a workstation So you can practice brute forcing weak passwords. You can practice some standard IT security attacks. That HMI is talking to a software OpenPLC. So that PLC is talking over Modbus. So you can practice doing a man-in-the-middle attack. So faking out the HMI and PLC communication and sending false values to the HMI. And then when in reality, the 3D simulation of the chemical process is showing that the pressure is increasing and then eventually causing an explosion in the reactor. That PLC also has a vulnerability in the Modbus library. So you can also, if you're really into the technical details of IT security, you can practice your buffer overflow exploits and get like a shell on the PLC and mess around there. And finally, that PLC is talking to some simulated remote I/O, again, over Modbus, where you can practice that man-in-the-middle attack. And all of this, again, is being visualized in this 3D game engine. So trainees can understand and appreciate, if I send false data to the HMI, I can then hide my attack that's causing the reactor to explode or other physical consequences. So the chemical simulation that we had is actually taken from the simplified version of the Tennessee Eastman challenge process. Is a paper published in like 1990, I believe. Just a chemical simulation challenge that it's more efficient at high pressure, but then you have to balance the need with keeping the pressure below the safety limit. So the initial paper was releasing Fortran code to simulate the process and giving process engineers a nice little example to play around with and design new control algorithms. So we took that, kind of upgraded it from Fortran to modern day languages and used it for our purposes in the simplified version. So it's just it's an exothermic chemical reaction, 2 input feeds, 1 product output, and a purge valve. And again, all this is visualized in the 3D game engine there at the screenshot there. The main idea being, so displaying all those same key measurements that are being shown on the operator's HMI, but if you're practicing, for example, the man-in-the-middle attack, you can see the difference between here's the true values of the process, here's the HMI being lied to. The operators are seeing everything's fine, but in reality, the process is getting messed up. Someone's attacking it. So I mentioned earlier OpenPLC. It's a free and open source PLC implementation. We implemented on Linux. So it's a software PLC. There are hardware versions of it, but it's a lot easier to just go with the software version. It uses a free open source PLC editor using the standard PLC programming languages. For the HMI, we use Advanced HMI. Again, it's free open source .NET application, Windows HMI Builder. So we have a very basic HMI watching the chemical process. So just going over some examples of the kinds of attacks. Again, this is a complete full virtual network. So any attack that's possible in the real world is possible in this virtual network. So we have just the really standard stuff, network scanning, seeing what ports are open, what's on the network, doing the man-in-the-middle attack, sending false data to the operator's HMI, denial of service, so freezing the HMI, or preventing measurements from getting to the PLC, updating the control actions. You can also practice reprogramming the PLC with malicious ladder logic programming. And of course, you can practice common IT security attacks, so password cracking, buffer overflows, and other advanced exploits. So I don't know if this, okay, there we go. Yeah, so when you successfully get the pressure above the threshold, nice explosion animation happens. If you had sound on here, you hear sirens going and smoke crackling. So it's creating a more engaging learning environment to really encourage students to practice with it and play around with it. So once you practice thinking like a hacker and practicing all those attacks, you can go back then and practice defending from those attacks. So one of the first steps is proper network segmentation. So you can practice segmenting the network properly with firewall rules, redesigning the architecture there, practice some basic network monitoring for taking some sample network traffic and analyzing who's talking, what's going on, and practice some basic intrusion detection. So like downloading, so Snort, for example, is an open source free intrusion detection systems you can practice with. And if you can set it up as the Purdue reference model, so breaking up into the level 0 down with the remote I/O modules and the PLC at level 1 and the HMI engineering station at level 2. Just kind of summarizing the benefits again here, this is a real virtual network. You can get real hands-on experience with both the security aspects, practicing these attacks and defenses, but also for people coming from the IT side, giving them a virtual PLC to play around with, actually understand how those work, how those are programmed. Also firewall configuration, network monitoring. It's a lot more engaging than current options, 3D environment, and most importantly, it's free and open source right now on my personal GitHub. Future plans, current work. Right now, you probably do need a little bit of Linux experience just to set it up. It's not that easy to set up and get going. We're trying to make that more user-friendly as we go. Also providing a wider variety of scenarios. So a chemical plant may not appeal to someone from the water industry or the power industry. So we want to create basically a library of example scenarios that would appeal and relate to anyone from any background, essentially. We're also looking to cloud deployment to scale to larger networks, make it easier for people. That's actually what my own company is doing right now is setting up a commercial training solution, but deploying it in the cloud so the end user doesn't have to go through all that themselves. Creating a whole curriculum behind it. So it's one thing to have a sandbox to play around in, but also need to educate people on the kinds of attacks and what they can actually do with it. And finally, adding some gamification aspects of it to make it even more engaging. So adding like a whole background story to it, adding specific missions, keeping track of scores and achievements, just increasing that engagement to really encourage more students to get into it. And with that, I'd like to thank you for your time, and I'd be happy to answer questions at the end of the panel. Thank you.